In the name of God, my presentation is about determination of anticoagulant and procoagulant fraction isolated from Iranian X-kinase venom in order to bioinformatic studies of these effects. My supervisor are Dr. Hossein Watanpour and Dr. Nasra Mohammadpour. My advisor is Dr. Aminu Ahmadnejad. I am from University of Medical, Sheikh PhD University of Medical Science. Over the last several decades, research on snake venom toxins has provided not only new tools to decipher molecular details of various physiological processes, but also an inspiration to design and tools for and develop a number of therapeutic agents. Snake are classified three families: Glabrida, Lapida, and Viperida families. A large percentage of venom is made up of proteins and amino acids. Other components of venoms are lipids, carbohydrates, nucleotides, and inorganic compounds. Types of venom toxins have evolved to specifically target various critical points in the physiological systems of prey animals. Neuromuscular and circulatory systems are the two main physiological systems that are targeted by a great number of toxins. Snake venoms are affected of circulatory systems such as Viperida families. Snake venoms are affected neuromuscular systems such as sea snakes and some of the Lapida families, and other venoms are affected on the cardiovascular system such as members snake. Venom proteins affect blood coagulation can functionally be classified procoagulant and anticoagulant proteins. Anticoagulants are proteins and phospholipids, and procoagulants are serine proteins or metalloproteins. Viperida venoms mainly cause hemorrhagic and coagulation disorders and as such provided a rich source of pharmacological active proteins and peptides for studying the clotting cascade as well as platelet glycoprotein receptors. The Iranian X-kinase is one of the most dangerous viper snakes. Its venom causes severe blood coagulation manifestations in patients. Scientific names X-kinase sakuraki, English name sand skull viper, and Farsi name Jafari snake. The geographical distribution of X-kinase when snake in Iran. Method. My tools to protein concentration lure method, LD50, sperm and carbon method, molecular weight, gel electrophoresis, anticoagulant and procoagulant and platelet aggregation activity, PT, APTT and platelet aggregation activity test, molecular and electric bar values of perfect fractions, mass spectrometry. The venom is of X-carinatus lyophilized and then for extraction is used size X for purification. We use size exclusion chromatography. For S-step purification, we use ion exchange chromatography, and final purification, we use high performance liquid chromatography. For next step, we use STS page electrophoresis for exhibit the 1 pound of profit fractions on gel electrophoresis. Then I cut the 1 pound on from gel, and we send this uh, mm, 1 pound for multi-top mass spectrometry. In final, we use Mascot database for determination of these fractions. Alignment, the class cell bioedit, and blast to calculate. We use this software for alignment analysis. For bioinformatic analysis, we use Modeler. The SPSS and Prism are used for analysis, statistical analysis. Result and discussion. In this slide, we show the result of plasma clotting times and other clotting tests of venom of different concentrations of crude venom. We show this slide the result of purification of crude venom. We obtained 5 fractions: F1, F2, F3, F4, and F5. The clothing time tests are carried for all of the fractions. In this slide, show the F1 and F2 are selected as procoagulant fractions, and F5 are selected for anticoagulant fractions. The clothing time of F1 fractions, the clothing activity of F2 fractions. This slide of STS page profile of crude venom and fractions and of its fractions. The anion exchange chromatography of FPH fractions. The result of clothing time test of fractions, sub-fractions of FEH fraction. Clothing activity of in this step, we F1 5 fractions, sub-fractions is selected for procoagulant fractions. The clothing activity of F1 5 sub-fractions. This slide, the anion exchange chromatography of sub-fractions of F2 fraction, the anion exchange chromatography of F5 fraction, the result of clothing time activity. F2 for sub-fractions is selected for procoagulant fractions. The cation exchange chromatography of F2 for sub-fractions. The result of clothing time activity of F2 for 2 sub-fractions. The HPLC chromatography of FEH fraction. The HPLC chromatography of F2 fractions. The HPLC chromatography of F4 fractions. The HPLC chromatography of 5 fractions. The result of clothing activity of sub-fractions result sub-fractions obtained from HPLC chromatography. The aggregation activity of F1 and subfractions of F1 fractions and crude venom of venom. The aggregation activity of other fractions. In this slide, show the F1 and subfractions of F1 fractions. Show the aggregation activity, inducer aggregation activity. In this slide, we show the hemorrhagic activity of this crude venom and other fractions. The single bond of purified fractions, F1 fraction in reduced and non-reduced state, single bond of F242 and F51 subfractions, procoagulant agent, the spectrophotometry spectra of procoagulant fraction. The result of mascot research in F1 fractions that show the procoagulant activity, power procoagulant activity. As I show in this slide, we calculate these fractions is zinc metalloproteinase with a distinct green-like domains. This table show the match of proteins in database research with my fractions. Alignment of these my fractions. The 3D structure of my fractions by modular software. Is one of the procoagulant fractions is very similar to my fractions, is occurring from a cell-scale Viper X carinatus. Toxins is one of the procoagulant fractions from snake Venoms, is similar to my fractions. Anticoagulant agents, mass spectrometry spectrum from anticoagulant fractions. In this slide, we show the result of mascot research that show the basic phospholipase A2. My anticoagulant fraction is phospholipase A2 is similar to phospholipase A2 from snake venoms. This table show the similarity of proteins in database research with my fractions, anticoagulant fractions, alignment of my fractions, the 3D structure of my anticoagulant fractions. Phospholipase A2 are classified acidic and alkalitic and neutral. Phospholipase A2 in this slide, 2 phospholipase A2 from other snake venoms that are similar, very similar to my fractions, to my anticoagulant fraction. My anticoagulant fractions same as the two properties. It is anticoagulant and anti-aggregation activity. It is block the aggregation activity, similar that to fractions. Phospholipase A2 from other SNAC venoms. Antiplatelet agent. This spectrophotometry of antiplatelet fractions. It is distinguishing cystatin-like. It is show the similarity for distinguishing cystatin from X carinatus SNAC venom. This table show the similarity of my fractions to other peptides established in database research. The alignment of distinguishing my fractions, antiplatelet fraction, the 3D structure of antiplatelet fractions, my antiplatelet fractions. In this slide, show the similarity of 3D structure of my antiplatelet fraction to cystatin, to 3D of cystatin. Cystatin is antiplatelet fraction from X carinatus SNAC venom. In the name of God, there are thanks.